Hi, welcome to a new session of Circuits and Networks. In today's class 16, we are going to see the transient analysis of RLC circuit with the help of MATLAB approach. And we need to solve before MATLAB the solution using differential equation. So here you can see there are two circuits. One is the original circuit and one is the MATLAB circuit. In MATLAB circuit, we have taken the example of 40 volts as input voltage, 20 ohms as resistor, L value as 4 Henry and capacitor value as 0.05 farads. So what we should know from our previous classes, the difference between RL and RC circuit when the switch is closed and the current starts flowing, the current through RL circuit is obtained to be V in by R 1 minus e to the power of minus R by L into T, whereas in RC circuit, I of t is given by V in by R e to the power of minus 1 by RC into t. What is the difference? The current through RL is increasing, whereas the current through RC is exponentially decreasing. So this is the basic difference between RL and RC circuit. And if at all you look into the graphs, the exponential rising curve and exponentially decaying curve seems to be looking like this. So when we have seen this RLRC circuit in a MATLAB model in our previous classes with this input as 100 volts, voltage and resistance value as 50 ohms, inductor value as 100 millihenries and capacitor value as 100 microfarads for respectively RL and RC, the waveforms obtained to be, it is shown here over the current, the voltage and the inductor voltage. You can see for RL circuit how the current is increasing, the resistance voltage is also increasing because resistor in resistor the voltage and current will follow the same waveform but the amplitude will be different. Okay, so you can see the current is rising from 0 to 2 amperes, and when that is multiplied with 50 it becomes 0 to 100 volts. So that is the important thing you need to observe over here. And voltage across inductor is exponentially decreasing. Coming back to RC circuit, it happens quite opposite to the RL circuit. You can see the current is exponentially decreasing, and pertaining to the current, the voltage across resistor is also decreasing. The current is decreasing from 2 amperes to 0 and voltage from 100 volts to 0. Whereas the voltage across capacitor, it is exponentially rising. So this you should know before solving the RLC circuit. So when the RLC circuit, when you look into the condition for t greater than 0, the current when it starts flowing, the voltage relation is obtained to be V in is equal to the voltage that across resistor, inductor and capacitor. And when you differentiate this equation 1, we are going to get this equation, that is d square I by dt square plus R by L di by dt plus 1 I by LC equal to 0, and represents second order differential equation. So the auxiliary or characteristic equation for the equation 2 is obtained to be s square plus R by Ls plus 1 by Lc is equal to 0. This equation 3 has roots of S1 which is obtained to be minus alpha and beta. What is alpha? Alpha, you can see it is R by 2L, and beta it is under root of alpha square minus omega naught square. What is omega naught? That is 1 by under root LC. It's a basic mathematics. You should know how to find out the roots for the auxiliary equation of this characteristic equation which is given equation 3, and the particular solution for this is obtained to be I of t which is equal to k1 e to the power of s1t plus k2 e to the power of s2t. So the k1 k2 roots can be determined from the initial conditions, and we have three different conditions when alpha is greater than omega naught, alpha is equal to omega naught, and alpha less than omega naught. And the solutions are obtained to be r by 2l which is greater than 1 by under root LC. The value of alpha is r by 2l here. So the roots here becomes real and unequal, and the system gives an overdamped response. So the solution is given by k1 e to the power of s1t plus k2 e to the power of s2t. For alpha equal to omega naught, you're going to get the roots are real and equal. What is the difference between case 1 and case 2? In case 1, the roots are real and unequal, whereas in the case of 2, the roots are real and equal. Therefore, the solution will be the I of t equal to e to the power of minus alpha t of k1 plus k2t. And for the third case, the roots are complex conjugate and the system is treated as underdamped system. And the solution for this is obtained to be I of t is equal to k1 e to the power of s1t plus k2 e to the power of s2t. Again, s1, s2 roots are classified as uh, j omega d, where omega d is equal to under root of omega naught square minus alpha square. And the solution of I of t, if at all you elaborate, it becomes e to the power of minus alpha t of k1 plus k2 cos omega dt plus j k1 minus k2 sin omega dt. Now this analysis or this concept of RLC circuit, it is very useful for ECE related engineering or electrical engineering, especially when you learn about signals and systems, control systems, power electronics. So this concept gives very basic information. So this is a very important concept. You cannot ignore the transient behavior of RLC under DC or later on AC or for different input signals. When you take an example so that you can understand the concept in a much better way, like 40 volts DC is selected for 20 ohms, 4 henries and 0.05 farads. So when you take the conditions of initial current and voltage, you are going to get the values of current and voltage across the elements, that is the passive elements, as zeros. And for t greater than 0, the circuit closes and we apply the KVL. We frame the standard equation 1. When you differentiate this equation 1, we are going to get equation 2, and this represents again a second order differential equation. So the auxiliary equation here changes to d square plus pi d plus phi equal of I equal to 0. You can obtain the roots for this auxiliary equation with the d1 value and d2 value as minus 1.38 and d2 as minus 3.618, and I of t will be equivalent to k1 e to the power of this d1 term and d2 term. Now for initial conditions, we have to obtain what is k1 and k2. For that, when you take the initial conditions, I of 0 plus is equal to 0, you're going to get 0, which is equal to k1 plus k2. Let us treat this equation as 5. And when you take from equation 1 and apply initial conditions, you're going to get di of 0 plus by dt as equal to 10. Now, differentiating equation 4 with respect to t, we get this equation, that is di by dt, which is equal to this equation. And from equation 6, we know that di of 0 plus by dt equal to 10. So you substitute these values, equation 7 and equation 5 will give you the value of k. The k1 and k2, once they are obtained, if at all you substitute in the equation of I of t, you are going to get 4.468 of e to the power of minus 1.38 t minus e to the power of minus 3.618 t. Now this is a solution what we have obtained for I of t. Now let us go with the MATLAB approach. For going for the MATLAB approach, let us go with the circuit. Here you can see a 40 volts is selected. Okay, switch is connected and resistance is taken as 20. Okay, inductor value is taken as 10, or you can take here 4 like this. So inductor value is changed to 4. Capacitor value also you can check. It should be 0.05. So I have selected the values. Okay. Now after selecting this, you can see I have connected voltmeters across resistor, inductor and capacitor, and also current is flowing through the RLC circuit. For that you have an ammeter and all the responses are taken on this particular scope. Let us run this and check what is the condition we are going to get. Yeah, so you can see here the waveforms. Yeah, you can see the resistance waveform, it is rising, whereas the inductor voltage, it is dropping. Capacitor voltage is also rising and current through the circuit is also rising. Whether it is the load current, line current, or inductor current, once in a RLC circuit, it becomes all the current becomes equal, and that is nothing but the current which is flowing to the passive elements. So that is the current which is flowing over here. In order to understand this concept in much more better way, what I'm going to do, I'll remove the switch, okay, and once I'll apply this 100 volts with different values of resistor like 50 ohms, 100 microfarads, and what is the value of inductor here? You can see 100. E power minus 3 indicates milli henries, and if at all you run this for 0.4 seconds, so what is the waveform you're going to get here? You check the waveform, you can see the voltage across resistor is 0, the voltage across inductor is 0, the current in the circuit is 0, only you have capacitance voltage, and that is equivalent to 100. How this can be studied? You see 100 volts is the supply, okay, and for the steady state conditions, inductor becomes short circuit and capacitor becomes open circuit. When this is shorted and this is open circuited, 100 volts is directly applied across capacitor, so the same 100 volts is showing over here. You can see here 100 volts is we are obtaining across the capacitor, and since the circuit is open, how the circuit would be? The circuit would be like this. You have this circuit, you can see here I am taking this circuit. The open circuit means you can remove this inductor, you can remove all these things, okay, just you can connect a line over here like this, so this becomes open circuit, and when this is open circuit, okay, the 100 volts is going to be obtained across this particular value. So whatever the voltage which you measure, that is the higher potential, lower potential, you will get the same value of voltage as 100 volts, whereas current will be 0, okay. So this is the catch. Now what happens if at all I place switch? If at all I place switch, I'll be obtaining the same result, but what is happening through 100 volts connected through the switch, that you can study easily by connecting the switch. See how the waveforms would be. Yeah, you see here the end result is the voltage across resistance is 0, okay, and inductor voltage is also 0, fine, whereas the current through the circuit is also 0. But what has happened because of the switch? Because of the switch, the waveform has taken the shape of overdamped. Overdamped in the sense, because of the switch, the voltage across the resistance is following the current through the circuit. That is what it is changing the transition time from 0 to 0. It has taken some time to reach the conditions, whereas the voltage across capacitor, you can see it is slowly increased to 100, and this has happened only because of the switch. If at all you remove the switch, like I'm showing you over here, I'll remove the switch, then what has happened? I have connected the circuit like this, again I'll run this, then the transient behavior, that is the behavior of overdamped system, will be gone. Okay, you can see here uh, voltage across resistance is 0, inductor voltage is 0, current through the circuit is also 0, whereas the voltage across capacitor is 100. So this is the important thing that you should keep in your mind while solving the circuit. So let us go back to our PPT. So what we have seen, with 40 volts, 20 ohms, this kind of steady state conditions we have reached. And when you apply the same for different values of inductors and capacitors, like 100 millihenries and 100 microfarads, we have observed that behavior of the switch under transient conditions, and the waveforms are obtained to be like this, where open circuit becomes the open circuit voltage of the capacitor, that is the 100 volts, and that is what we have seen over here. So I hope you like this class. Please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. Thank you.